Hi everyone, my name is Wyatt Hall, and this is my capstone for ACTE 651. My activity involves robotics programming. So, my activity, I actually pulled the initial activity from the 2012 PATSA event booklet. This event was designed for calculator robots. We're using a graphing calculator to uh, program a robot to navigate a course. And I modified and added onto this as an extension of the robotics coding and programming unit that I currently do teach. So my current unit, students learn how to program and use ModKit. They write their own code, program the robot to navigate around an island in my classroom. Basically, they're just plugging in distance commands, and they pull their measurements from the floor and then input those measurements into the computer. Before I go over my activity, I want to go over my lesson goals here. Uh, Through this activity, I'm hoping to improve critical thinking in my students. It's pretty challenging to complete this task in only 3 attempts, so they have to really get things right the first time so they can make minor adjustments on their second 2 attempts if necessary. I'm also hoping to improve communication skills in my students. They are working in groups for this. It'll be groups of 2. And the last thing is to apply prior knowledge from multiple disciplines to develop a solution. So they're going to have to use knowledge from both my class and math to come up with a solution for this activity. All in all, these goals, I'm hoping to improve 21st century work skills in my students. So this is my activity here. My students are going to have to navigate the course going through. The robot's going to start at the first tile here, which is the X. Going through the course, they have to figure out the angle here, use the Pythagorean theorem to develop their distance across these 3 tiles. Going into the launch pad area, the robot needs to back up, activating a bumper sensor. Once the bumper sensor is activated, then they have to develop a code for a countdown that's going to be displayed on the robot screen. Also, this activity, there's a time limit, so the robot needs to finish between 28 and 32 seconds, which means they'll have to adjust the speed of the robot to complete this in the allotted time. And the last thing is there's an attempt limit on things. I put it at 3 attempts because I don't want students to come over and constantly practice and test their robots. I want them to apply that prior knowledge to get it right on the screen the first time instead of trial and error testing the robot. So before I get my demonstration here, levels of inquiry, this is a guided inquiry example, level 3. So I'm providing the design challenge and problem. Students have to design and code and program their robot to solve and to develop their solution. So this is my demonstration. I use ModKit, which is new. I haven't used this in the classroom actually, ModKit yet. I used to use Robotsy, but it's been giving us a few issues. So you can see my code here on the left. This is the code just to navigate the course. And then we have the bumper sensor code kick in, and then the code for what's going to be displayed on the screen. So my demonstration here. Once I push the button, my robot has to travel 32 inches, and then we have a 90-degree turn. Then it has to travel another 24 inches. Then we have a 45-degree turn, 28 inches using the Pythagorean theorem, 45-degree turn, and then we got a range from 15 to 25 inches into the launch pad, and then you'll see our countdown. And liftoff should come into focus here. 4, 3, 2, 1. Liftoff. So that's my capstone. I hope you enjoyed it. Take care.